Hi, it's Noah here. You know me as Nguyen from Northeastern University, and today I will walk you through a problem in my final project for CS1800. Okay, so now the problem is that we need to prove that 9 to the power of n minus 1 is divisible by 8 for all n larger than 0. Firstly, when I look at this problem, my intuition reminds me of the rules of divisibility, multiples, and factors. So looking at this definition over here, applying it to the problem, we can say that a number is divisible by 8 when they have a remainder of 0 and the result of the division is a whole number. So let's say that a and b are some positive integers. So a is divisible by 8 if a is equal to 8 times b. A is a multiple of 8 and b here, and 8 and b are factors of a. So now to tackle this proof, we must factor out an 8 to show that it is divisible by 8. So before we prove, we need to believe that this statement is true. Therefore, I previously wrote some code in Java to test for n from 1 to 10, and as you can see over here, it is all shown to be true. So now let's start with our formal inductive proof. So we will now prove this by induction, weak induction. So firstly, our claim is that p of n is that 9 to the power of n minus 1 is divisible by 8 for all n greater than 0. So now we need to set a base case to test if this statement is true. So in this case, I'll set my n to be 1. So p of 1 is equal to 9 to the power of 1 minus 1, which equals to 8, and 8 divided by 8 is 1 with a remainder of 0, so it is divisible by 8, so therefore our base case is true. So now we'll consider our inductive hypothesis for k. So we assume that p of k is true. So this means that 9 to the power of k minus 1 is divisible by 8 for k greater than 0. So we can say that 9 to the power of k minus 1 is equal to 8 times a constant big A, while big A is greater than 0. So now we will try to prove that p of n holds when n is equal to k plus 1. So first we have 9 to the power of k minus 1. So we can separate 9 to the power of k plus 1 to 9 times 9 to the power of k by indices law. So since negative 1 can be represented as negative 9 plus 8, we can now replace it negative 1 with negative 9 plus 8 here. So now we can see that we can factor out a 9 from this part of the equation. So now we have 9 to the power of k minus 1 here. So by our inductive hypothesis, it is 9 to the power of k minus 1 is equal to 8 times a constant big A. So now we have 8 times big A times 9 plus 8. So finally, we can see that we can factor out an 8 from this. So this means that 9 to the power of k plus 1 minus 1 is a multiple of 8. So since it results in a multiple of 8, it is divisible by 8. So p of k plus 1 is therefore proven to be true. So therefore we can conclude that since p of 1 is true and p of k implies p of k plus 1, p of n is then true for all n greater than 0. And this is a summary of every step I've done in this video. So first we have our claim here, and we need to set a base case to test if our claim is true for at least n equals to 1. So now we assume that p of n holds when n is equal to k, and this is our inductive hypothesis. And then we need to prove that p of n holds when n is equal to k plus 1. And after we have proven it to be true, we can safely say that it is true for all n greater than 0. Thank you for listening, and bye.